What's up, the internet? We got a fun calculus problem given to me by a student here that I thought I'd do a little walkthrough of. So the problem is the limit as x goes to 0 of tangent 2x over 6x times the secant of 3x. And most students when they look at that problem will just say, what has happened to me? This is a monster. How could I possibly untangle this beast? And basically quit before they start. When it comes to tricky calc problems, we can't possibly know how to do them by looking at them. What we can do is try to figure out what's the next step. And by doing that, we'll be able to see one, maybe two steps ahead of us and eventually get to the end of the problem. So always, 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 when doing limits, evaluate the limit point directly by simply plugging in 0. Sometimes that will work. What it will always do is tell you what kind of creature you're dealing with, which will enable you to use the right tools to break it down. So here, if we plug in 0, we get 0 over 0, which is an indeterminate form, meaning we don't know what it means. Okay, so now I see tangent, I see secant, and I'm thinking to myself, well, those are made out of cosine and sines. And so often it's helpful to go back to the original building blocks of cosine and sine. So we do that here, and we get sine 2x over cosine 2x, and 6x over the cosine of 3x. Okay? Now, instead of dividing by a fraction, let me multiply by the reciprocal. So I flip that bottom fraction, and I get what you see there on the right. Now I notice, wait a second, I have a sine of 2x over a 6x. Now I know that the sine of 2x, or put simpler, the sine of x over x, the limit of the sine of x over x as x goes to 0 is 1. So maybe I can create that. So I'm going to rewrite this as the sine of 2x over 6x down here, but I'm going to rewrite 6x as 2x times 3. And what that does for me is in the next step I can pull out this 3 as a third here, and now I have sine of 2x over 2x. And of course this is the same thing as sine of x over x, because I can just simply define 2x here as a new variable y. Meanwhile, what's left over is cosine of 3x over cosine of 2x. Okay? Now I can simply evaluate the limit. This is an identity limit. If you're asking why is the sine of a over a as the limit as a goes to 0, 1, we could look that up. We could do that in a different problem. But it's an identity limit. You're allowed to use that whenever you want. Meanwhile, the cosine of anything as the anything goes to 0 is 1. So we end up with 1/3 times 1 times 1 over 1, which of course equals a third. If you have any questions, please post them in the comments to the video, and I'll make another video addressing your questions. And if you're interested in tutoring, I run Addison Academy, boutique tutoring operation for the last 7 years, and it's been a lot of fun. So please reach out, and I'd love to work with you. Have a great day.